Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Large-Scale Structure of the Universe. So what do we see here? Well, here we see an image putting together part of a map of 47 million galaxies that have been studied by DESI, or the Dark Energy Spectroscopic Instrument, which is at Kitt Peak National Observatory in Arizona. Over the last 5 years, it completed this survey of 47 million galaxies, both ordinary and active galaxies known as quasars. And it's putting together a 3D map that is centered on Earth. So here in this image, Earth would be at the center. And what we're seeing is some of the distant structures in the universe. And each little section represents galaxies and clusters of galaxies. And we see that the universe has formed into great filaments and voids. So the material tends to be concentrated in specific areas, falling along filaments that stretch across large chunks of the universe. Now, how these structures form depends on a couple of things. It looks at gravity, and that can be gravity with ordinary matter and dark matter, which will affect the building of material, how material will group together. So the more material you have there, the more things will gather. And in fact, we find that we need dark matter, a matter that we cannot see, in order to explain the structures that are visible in the galaxy today. Otherwise, under our current models of gravity, these should not have formed with just the visible matter that we see. Just that ordinary matter is not sufficient to form the structures that we can see, as in this image, that they are present in the universe today. Now, gravity is caused by those two, but there's also another force that is involved known as dark energy. And that's really what this is going to look for, trying to learn more about this form of energy, which is causing the universe to accelerate. So normally we would think that the universe would start expanding at the Big Bang and would slow down a little bit over time. That's just because the gravitational force would pull galaxies together, and that would slow them down. However, what we find from more recent studies is that the universe is actually accelerating. It is expanding faster now than it was before. And that led to the idea of dark energy, a sort of pressure within the vacuum of the universe that pushes things apart. It was not important in the early history of the universe, but as the universe expanded, it became more and more important and causes the expansion of the universe to not slow down, but to instead accelerate. Now, as you look at this image, you notice that there's two big gaps there, one to either side. That's because of our galaxy. Our Milky Way is causing problems for us here. When we look within the plane of our Milky Way, we can't see out very far. There's too many stars and too much gas and dust there blocking out all of that light. And that keeps us from being able to see in those directions. When we look out perpendicular to the plane of our galaxy, then we see each of the two sections at the top and bottom of the inset image here. So that's what those big black areas are. They're areas we simply cannot know about because we can't see them through our own galaxy. So there are some interesting findings coming here. Then the possibility that the idea of dark energy is not actually a constant. So it's thought it might be constant. Early studies of this show that it might not be. But now that we have the complete data set, as that analysis continues, we may find out indeed a little more about dark energy. So that was our picture of the day, titled Large-Scale Structure of the Universe. We'll be back again tomorrow for the next picture, previewed to be Young Moon and Sister Stars. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.